Lesson 6.1, the law of sines. The law of sines allows you to solve a triangle, which means that you find all the side lengths and angle measures. You can use the law of sine to solve a triangle if you know two angles on one side, which would be ASA or AAS if you remember your geometry, or two sides and one opposite angle. That would be SSA if you remember geometry. If you remember geometry, SSA was not a congruence theorem. ASA and AAS were. SSA has some issues. The law of sines is sine of A over A equals sine of B over B equals sine of C over C. Notice in the picture that side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So the side is a lowercase letter, and it's opposite the angle, which is the uppercase letter. So let's solve a triangle where angle A is 30 degrees, B is 45 degrees, and side A is 32 feet. So it might be useful to have a triangle. Call this A, B, C, 30 degrees, 45 degrees, and this would be side A, which is 32. This would be side B and side C. All right, so I know the side A's. I have two angles and a side, and it's the side is not between the angles, so this is a AAS case. I know the A's, so I'm going to have sine of A over A, and since I know angle B, I could find side B, so it'll be sine of B over B. So it'd be sine of 30 degrees over 32 equals sine of 45 degrees over B. If we cross multiply, we'll have B sine of 30 degrees equals 32 times sine of 45 degrees. Of course, sine of 30 degrees is a half, and sine of 45 degrees is square root of 2 over 2. So if I multiply both sides by 2, I'll get 32 square root of 2, which is approximately 45.25 feet. All right. Now, to get the angle C, the three angles in a triangle add up to make 180 degrees. So angle C would be 180 degrees minus angle A minus angle B. So it would be minus 30 degrees, 45 degrees. So C would be 105 degrees. And now that I know angle C, we can find it. Now, we could use either the A's or the B's. I'm going to use the A's because I know them exact and they were given to us. Just in case I made a mistake in calculating side B, I'm going to use the numbers they gave us if at all possible. So I'm using the A's and then angle C. So I know angle C, find side C. So A was 30 degrees, side A was 32. Angle C is 105 degrees, looking for side C. Cross multiply. divide by the sine of 30. And C comes out to be about 61.82 feet. And if you want to do a quick double check, the longest side should be opposite the biggest angle, and the shortest side should be opposite the shortest angle. So there we go. There was side B, angle C, side C. We now know everything in the triangle. But let's take this ambiguous case, the SSA case, the one that has issues. All right, for all our examples, we're going to say we're given angle A, and side B. So if you're given other things, you could just substitute the letters for A, and B. So if angle A is greater than 90 degrees, and side A is less than or equal to side B, then there are 0 solutions. So you can see in the picture, side A would be just too short to make a triangle. But if A was greater than B, then you'd have exactly one triangle. If angle A was less than 90 degrees, and A equals B sine of A, so that height there, side A, if equals B sine of A, then there's one solution. If A is greater than B sine of A, and A is greater than or equal to B, then you have one solution. The B sine of A would be like the height in the middle. So side A is longer than the height, and it's also longer than side B. You get one triangle. If A is less than B sine of A, again, B sine of A is like the height. If A is shorter than that, there's 0 solutions. It's too short, it can't make a triangle. But if B sine of A is less than side A, and A is less than side B, you get 2 solutions. So you get the outside triangle, or you get this inside, the smaller triangle here. In both cases, either the outside or this yellow one, angle A is the same angle, side B is the same length, and side A is the same length. So it's like side A pivots on point C and can go either way along the bottom to make 2 different triangles. So let's solve triangle ABC, where angle A is 58 degrees, side A is 4.5, and side B is 5. All right, this is a SSA case. Our angle is less than 90 degrees. All right, so we need to find out what B sine of A is. So B is 5, angle A is 58 degrees, and so that is approximately 4.2402. So if we compare this, we have A is less than 90 degrees, and we know that side A is bigger, we know that the shortest of these things is the B sine of A. The next shortest thing is the A, and the longest thing is B. Oh my, so that means there are 2 solutions. All right, it's really not that hard to do 2 solutions. It just takes a little more time. So for our first solution, let's call this angle A. This angle B. That one angle C. So this is side C. Side A, which is 4.5, and side B, which is 5. All right, I know the A's and I know side B, so let's start by finding angle B. So since I know the A's, it'll be sine of A over A. I'm looking for B, so it'll be sine of B over B. Angle A is 58 degrees. Side A is 4.5. I don't know angle B, but side B is 5. Cross multiply. And then to solve for B, I'll need to divide by the 4.5 to get the sine of B by itself. Okay, so that's about 0.9423. To find angle B, we'll have to use the inverse sign. So angle B is approximately 70.44 degrees. All right, now we could find angle C. Angle C would be 180 minus A minus B. So angle C is approximately 51.56 degrees. All right, now we can find side C. So notice we haven't done anything different yet because the first solution is just what you get when you solve it just using the law of sines, nothing special. All right, angle A is 58 degrees, side A is 4.5. Angle C is 51.56, and side C is what we're looking for. Cross multiply. And divide by the sine of 58 degrees. So side C is approximately 4.16. And that's our first solution. All right, let's do the second solution. All right, so first of all, let's come up with how we know what the second solution is going to be. All right, so this was our first solution. A is 58. This is side A, side B, which is 5, and then side C down here at the bottom. Well, if there's a pivot at point C, A could swing around to here so that this triangle is the one we're solving for. We'll call this B prime because it's a different angle B, and C prime because it's a different angle and side C. But this side is still A, which is 4.5. All right, so let's do a little geometry. This angle was 70.44. Because this triangle on the side is isosceles, that angle is also 70.44. So inside of this new triangle that I want for angle B, B prime, our new angle B, is simply the supplement of our old angle B. And that is always true. So you could kind of think of that as a rule. So the first angle we found was angle B. For the second triangle, the first angle you find is its supplement. So B prime will be 180 minus 70.44, which means it is about 109.56. And then we could find our other angle C. Now we just have this triangle, just solve the triangle like you normally would. So angle C is 180 minus A minus B, but it's our new B for our new triangle. A was 58 degrees, B was 109.56 degrees. So angle C is approximately 12.44 degrees. So that's everything except for side C. So for side C, I know angle A and side A, and I now know angle C. So I can say sine of A over A equals sine of C over C. And the primes because it's the second triangle. A is 58 degrees, side A is 4.5. All right, angle C prime was about 12.44, and we're looking for side C. So cross multiply. Divide by sine of 58 degrees. And so side C is about 1.14. See, not so bad. Area of a triangle. Area of a triangle is 1/2 base times height. However, if I use the triangle on the left, this one that I've just outlined in yellow, see it's a right triangle, and sine of A is opposite, h, over hypotenuse C. So sine of A is h over C. So if I multiply by C, C times sine of A is h. So our height is C sine of A. And my base is B, so my area is 1/2 the base B times the height, C sine of A, 1/2 BC sine A. Notice we have two sides and the other angle. So we can rearrange it so it's two sides and the other angle, or two sides and the other angle. That's all there is in this lesson. Have a good day.